Okay, now I want to show you how we are going to calculate a pressure or a submerged area of a tank. Let's see. I draw two tanks, and the first one is going to just have water up to this level. And the area of interest is going to be this piece. Let's name it. I'm going to call this height H1, this height H2, and the liquid was water. This is free surface. Okay, now let's write. First, let's draw the pressure over the surface. It is going to be like this. Because the liquid at the top and over this selected surface is same, so the pressure linearly is going to increase, and we don't have any breaking point over the inclined line of pressure. So if I draw again here, it is going to be something like this. But I'm just interested for this piece with height H2. So what I did is I selected this pressure and I converted to 2 or 3 separate areas. One, let me select green. One, this area, which I can easily calculate. Another triangle here, and a rectangle here. So let's draw a little bit much more clear. They're separate now. It is going to be like this. Okay, let's calculate the first part. So force for first piece, the resultant force is going to be here, and I'm calling F1. F1 is going to be gamma HCA, and let's call this A1, and liquid is same, so gamma would be same, and it is going to be gamma HC for that height is going to be half of H1 times area 1, which is going to be H1 times the depths, whatever is that. F2 is going to be this for resultant force for uniform pressure. F2. Because this is uniform, we already talked about it, you just need to know what is the pressure at the top or bottom? Because it's uniform, everything would be same. So it is going to be gamma H1 times area number 2. Great. The last one is going to be F3 here. F3 is going to be gamma HC A2. And we know HC for this time is going to be half of H2 multiply A2. Sometimes if you check some of the textbooks, they combine F2 and F3. Let's see if we combine those two, what we can get. If, for example, lower part is going to be summation of those forces, F2 plus F3, which is going to be gamma H1 area 2 plus gamma H2 half area of number 2. Let's simplify a little bit. Gamma and H2 we can factor, and it is going to be H1 plus H2 divided by 2. If you check textbooks, in the case of same liquids for the top and bottom side, they are going to suggest you using this formula for lower piece. But this is not the general formula. Usually we have the second case, or we could have the second case. Okay, let's start with the second one. We have now another liquid here, which is going to cover up to this level, and the second liquid would be under. So let's call this gamma Y for yellow, and this one gamma for B blue. And I am interested over this piece. Okay, let's draw the pressure prism. It is going to be something like this up to this level. Because liquid changed, pressure is going to change, and for example linearly going to increase, but we have a broken line at the interface of those two fluids. Again, same naming, H1, H2, okay, and I'm going to use the same for method we use for pressure. So let me draw these pressures separate as a separate pieces. This is the top part, uniform section, and prism shape. Again, I'm going to call them the resultant force for the first one, F1, and it is going to be gamma for yellow liquid times HC, area number 1, gamma of yellow Hc is going to be h1 divided by 2 and area number 1. This one is going to be named F2, which is going to be at the center, and F2 is uniform pressure, and we know how to deal with uniform pressure because this uniform pressure is because of the yellow layer of liquid. It is going to be gamma for yellow times height of that yellow times area of number 2. So we're done with this one, and number 3 is going to be this one. F3 is going to be gamma of blue HC area of number 2. Okay. So gamma of blue HC is going to be H2 divided by 2 times area of 2. Now let's combine F2 and F3 and see what is going to happen if we combine. For lower part, it is going to be F2 plus F3 gamma Y H1 A2 plus gamma B H2 half A2. Therefore, the lower part force is going to be, I can just take out area of number 2, and because liquid is different, I'm going to reach this formula, which is different from the case we had for same liquids. Okay, and you know how to calculate the height of the final resultant force. You just need to find a moment about this point or this point, and you can easily find the final resultant force. For example, here it is going to be Fr, here Fr, and you can find this distance. Let's call it HR. Okay, which is really easy. Okay, thank you very much, and see you next time.